friends, today we can see about Poisson distribution. What do you mean by Poisson distribution? Already we have seen binomial distribution. In that, a random variable it takes the finite number of values from 0 to n discretely an integer. Then what it is the probability mass function in that case. Now we consider a random variable capital X takes non-negative values is said to follow Poisson distribution if its probability mass function is given by P of x equal to x, that is equal to e power minus lambda, lambda power x by x factorial. X it takes value 0, 1, 2, 3 up to extra infinity. Here we say that when a random variable x, it follows Poisson distribution with only one parameter lambda and the lambda always greater than 0. One another note it says that Poisson distribution Poisson distribution is a limiting form of binomial distribution. What it is the meaning of binomial limiting form? Limiting form is nothing but as n tend to infinity and p tend to 0 in such a way that np equal to a finite parameter lambda. So Poisson distribution is always a limiting form of binomial distribution as n tend to infinity. That means the number of trials, it can be infinite number of trials, and the probability of success p, it tend to 0. That means very rarely occurs, closer to 0, in such a way that NP it comes upon finite parameter means we can say binomial distribution becomes Poisson distribution. Now we can see some example situations where we apply Poisson distribution. There are so many examples are there where we get the very rare P occurs and the number of trials it may be infinite. That cases we can see when an event occurs rarely, the number of occurrence of such an event may be assumed to follow Poisson distribution. Okay, example. One example I tell you, one example I write it on the board. The number of alpha particles emitted by a radioactive source in a given time interval. It is rarely occurs the particularly alpha particles emission in a particular interval. So this comes under Poisson distribution. And the number of defective articles in a packet of 1,000 articles. It is very rarely occurs out of 1,000 defective articles. One another example, the number of printing errors at each page of a book. This is one another example. Now we can see the derivation of MGF. MGF means moment generating function, mean, variance, and standard deviation. First, we can start with MGF. MGF, its notation mx of t, that is equal to, in E operator, we can write it as E of e power tx. That is equal to e power tx into the probability mass function comes under summation when x follows discrete distribution. So a summation over x equal to 0 to infinity e power tx e power minus lambda, lambda power x by x factorial. The whole thing comes inside the summation. That is equal to summation x equal to 0 to infinity e power e single base we can write e power t lambda the whole power x. The power x commonly we can take and one another e power minus lambda is there by x factorial. When we take e power minus lambda outside, summation x equal to 0 to infinity e power t lambda to the power x by x factorial. When we expand x equal to 0 to infinity, it comes a infinite series that represents nothing but the exponential function of a e power t lambda 1 plus e power t lambda by 1 factorial e power t lambda the whole square by 2 factorial etc. plus etc. it goes. So we can write this as e power minus lambda into e power t into lambda. When we take e as single base and minus lambda outside, that place it comes as 1 minus e power t. Therefore, MGF, mx of t of a Poisson distribution is e power minus lambda into 1 minus e power. This is important derivation. Okay, next we can get mean and variance from the derivation of MGF. Wait, I open a new slide to write it. Mean, its notation you know mu mu1 dash x bar. Simply we can write E of x. E of x is, how can we write by means of MGF? Mx dash of t at t equal to 0. Mx of t now only we found. So its first derivative we have to get it. That is equal to e power minus lambda 1 minus e power lambda. Its derivative at t equal to 0. That is equal to e power minus lambda into 1 minus e power lambda into minus lambda into minus e power t, its derivation. So the whole thing we have to substitute t as 0. that is equal to lambda minus into minus plus e power 0